Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Large Destruction by NXT Master. And here are the rules. We have standard irregular 7x7 Sudoku rules apply, except the given regions are false and must be destroyed by making sure none contain all digits 1 through 7. I would prefer putting it this way. In every cell in the grid, place a single digit such that every row and column contains the digits 1 through 7 exactly once each, and none of the designated 7-cell regions contain the digits exactly 1 to 7, 1 to 7 exactly once each. There will be unmarked regions which must be orthogonally connected, which contain the digits 1 through 7 exactly once each. And what does it mean to be orthogonally connected? It means that you can go from any cell in the region to any other cell in the region just by going through edges, all while staying within the region. So for example, this is a valid 7-cell orthogonally connected region. This would not be, because to get from this cell to any other cell in the region, you would have to go through a corner or get outside the region, which is not allowed. Something like this also would not be allowed, because to get even though these cells can get to each other by going through edges, all while staying within the region, they cannot go to any of the other cells in the region just by going through edges while staying within the region. So that's how I would put these rule set for that. Oh, additionally, the real regions, which do contain all the digits 1 through 7, must be deduced such that the digits in a circle represent how many of its surrounding 8 cells and itself belong to both the real and false regions the circle is in. Circles basically count overlap. So, as an example, this has 1 in it. That means in the surrounding 3x3, the 3x3 box surrounding that cell, the number of digits which are in the real region as the circle and the false given region as the circle must be 1. Well, it can only be this cell by itself, which means the other cells in this 3x3 area are either not in the real region or they're not in the designated false region. So obviously these could not be part of the real region because they're part of the designated false region. And if they were in both, this would not add up to just 1. So these are not part of this region here. So they would not be part of the pink region because they are already part of the designated false region. And in this 3x3 area, there's only supposed to be 1, which is itself. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. So what I like doing for these deconstruction puzzles. So for this one, we know the okay, so the boundaries are all the borders. We know there's a boundary here and a boundary here, because these are separate regions than this one. Because again, this 3x3 space has only one cell, which is both in the designated false region for the circle and the real region. And that can only be that cell itself. This can be 1 or 2, because there's only 2 cells in the 3x3 space centered on that cell, which are at least in the false region. So this is 1 or 2. This is up to 5. So this is 1 through 5, but no 3. This has 3, so it cannot be 1, it's 2 or 3. This has 4 at most, so this is 1, 2, or 4. This has 1, 2, 3, 4 at most, so this is 1, 3, or 4. This has 2 at most, so this is 1 or 2. Right? Because there's only 2 cells in the 3x3 box surrounding the cell, which can be even in the false region. And again, this counts both the number in the false region and in the real region. So we have a 1, 2 pair in row 4, which eliminates 1 and 2 in the rest of the row. This cannot be 2. This is 3. This can't be 1 or 3 now. So this is 4. This can't be 1, 2, 4. So this must be 5. So these are all in the same region. We're going to mark that as... I don't know what we mark that as. Then this must have all 4 be in the same region. So this is 4. This can have up to 5. So this is 2 or 5. This can have up to 4, but can't be 2 or 4. So this is 1 or 3. So if this were 5, that means all of these would be in the same region, but this can't be 4, and that would be invalid. So this cannot be 5. This is 2. Oh, wait, this is more than... This could be 6. Apologies. This is 2, 5, or 6, because I missed this digit here. It cannot be 6, because of the same problem that this would then force us to be 4. But it could be 5, right? It could be 5 here, and then this could be 1 by itself. This digit has, at most, 3 cells. Right? Oh, these 3 are the same region. So we're going to mark it that way. So therefore this can't be 3, this is 1. How does that work? That can't be the case. Hold up. That's... Oh, this is up to 5. Okay, never mind. Okay, I'm totally I missaw that. So this, again, is 4 digits. This is up to 6, and this has to be up to 5. But these are all the same region. So this cannot be 3. It can't be 1, because we already have 3 in the same region, so this must be 5. This can't be 5 here. These are already in the same region. That's greater than 2, so this must be 6. So these are all in the same region here. These are all in the same region. So it's green. These are all in the same region. We're going to make that orange. I guess we can make this yellow instead. So we'll make that yellow. This cannot... This is at most 3. Can't be 1 or 3, so this is 2. So this cannot be part of the yellow region. This cannot be the same region here. Because if this were the same region, then this would not be no longer be a false region. So this is done as a border. This is done as a border. Remaining digits in yellow region are 1, 2, 4, and 7. This can't be 1, 2, or 4, so this must be 7 here. Therefore, there's no 7 here. There's no 7 here. This can't be 2 or 4 because of 2 or 4 in the column. So this is 1. No 1 here in the row. No 4 in the column. So this is a 2. This cannot be the last 4. 4 can't be here. 4 can't be here. So that's done as a boundary. This can't be 4 here. So 4 for the yellow region must be here. So this is yellow. Actually, I guess we'll make that pink then. So this is pink. And this is a boundary here. This only has 2. So one of these is with it. We don't know which. We have a 6, 7 pair left in row 5. In row 6, we have 3, 5, and 6 remaining. In row 5, we have 1, 2, 3, and 7 remaining. And this can't be 1 because of 1 in the column. In row 3, we have 4, 5, 6, 7 remaining. And this can't be 4, 5 because of they're guaranteed these are in the green region. That means we can't be 6 or 7 in the rest of column 2. So there's no 7 here. There's no 6 here. We have 2 through 5 remaining then in column 2. This can't be 4 because of 4 in the row. Where's the 4 in column 2? It must be here. So this is 4 here. Orange cannot have access to a 4 because we already have a 4 in the orange region. This has 1. It could be part of green or could be part of some other one up here. Remaining digit in column 4 is a 5. Remaining digits in column 3 are 1, 6, and 7. But this can't be 1 because of 1 in the row. Remaining digits in column 5 are 3, 6, and 7. Okay. Um... So we are left with 4s in these 2 cells and these 2 cells. Because we have a 4 in all the other rows, 2 through 6, and columns 2 through 6, and row 1 and 4 through 7. So if the 2 went this way, the problem is it wouldn't access a 4. So the 2 cannot go this way. So the 2 has to access this way. So this will make this yellow. And it has to be one of those 2. This will then make it a blue. It cannot be part of orange. 1, 2, 3, 4, 5, 6, 7, 8, 9 orange. The blue needs access to a 4. Well, we got 1, 2, 3, 4, 5, 6, 7. So that's exactly 7 blue there. So this must be 4 here. That means this is done as a region here. So this has 2 cells, which are part of the real region and the fake region. So then this is 1. This 2 eliminates 2 in the rest of this row. 4 eliminates 4 here. So therefore, this must be a 4 there. This is yellow. I guess we'll mark this as... Maybe we should make this, instead of this being green, we'll make this red. So this is red. This will make green, and this will make gray for the 4s. Remaining digits in the blue regions are 1, 3, 5, 6, and 7. Yellow. This can't be 1 because of 1 in the column. This is not part of the green region, so this is part of red or medium gray. Cannot be part of pink. Red's too far over. Where's 5 for yellow? It has to be one of these cells. Okay. We need 1, 2, and 3 remaining for red. Okay. So that means this cannot be red. Also, yeah, this cannot be part of that cell here. So green can never go here or go here, right? Because red already has a 4. So green has to contain this. It has to go here. It has to go here, which means this cannot be medium. This is red. So green goes 1, 2, 3, 4, 5, 6 at least, and we don't know which one of these two it goes. Red could go here. Red cannot go here. This must be part of yellow. We have 1, 2, 3, 4, 5, 6, 7 yellows, and it cannot contain this, so this must be red. So this becomes a red-red pair. That's all of the reds here. This cannot be... Now 3 and 5 are both fine. No one here. So, where's the one in row 7? It cannot be in the yellow part, it's in the blue part, so therefore this can't be 1. We have a 2, 3, 7 triplet in row 5, which eliminates 2, 3, 7 in the rest of row 5, so this must be 1 here. Green can be either of these. Gray can be any of these. And orange can be up to 3 here. So 1, 2, 3. It cannot close this off because that would block this cell from being orange. Cannot close this off. Same problem. So any of these could be orange. 1, 2, 3. And technically these could also be orange. So this is definitely boundary there. Okay, this cannot be 5 here because of 5 in the red region. So this is 3, this is 2. That eliminates 3 in the rest of row 6 and 2 in the rest of row 5. This can't be 2 or 3, so this must be 5, which means this can't be 5 in the green region. We have a 6, 7, 6, 7 pair in the green region, so this cannot be 6 or 7. This is 1. We also have a 6, 7, 6, 7 pair in row 3, so this can't be 6 or 7. It's 5. Orange cannot go here because that would be 2 1s in the same region, so it can't reach there. We can't have 5 there either because there would be 2 5s in the orange region. So this must be 2 or 3 in the green region. In the yellow region, we cannot have a 2. So where's the 2 in column 1? It has to be here. So this is 2. The green needs access to a 3, so it gets to there. So this is green, which means it can't be green. Therefore, we know these are all medium gray because it can't be orange. Okay. Let's mark the 6, 7 pairs for letters. So we're going to make this A, B. Therefore, this is B, which makes this A. B is here, so this must be A, which makes this B. This can't be 1 anymore because of 1 in the column. No 5 either. We have 2, 3, 6, and 7 remaining. And this can't be 2 here. Whereas 2 in column 6, it has to be here. So one of these is orange, the other one is medium. If we try to go here as orange, there's only 6 cells in the orange region because it can't go here because that would block off the gray from being 7 cells. So this cannot be orange, therefore this is orange here. It has to, it's 1, 2, 3, 4, 5. This has to connect to here as orange, and it could be one of these two, which is not orange. So this is 3, 6, or 7. This is 3, 6, or 7. We have a 3, 6, 7 triplet in column 7, which eliminates 3, 6, and 7 in the rest of the column. This can't be 6 then. This is 5. No 3, 5, 6, or 7. This is 1. We have a 3, 6, 7 triplet in row 7, which eliminates 3, 6, and 7 in the rest of the row. So this is 5, which can't be 5. That's 6, which eliminates 6 here. That's 7, which makes this 3. This 6 eliminates 6 here, so it's 7. So B's have to be 6s, and A's have to be 7s. So this is 7. This 3 eliminates 3 here, so this is 7. This can't be 6 or 7. It's 3, which makes this 6. No 6s here. This can't be 6 or 7 here, so that makes this 3, which makes this 7, which makes this 3. And this can't be 6 or 3 or 6, so that's 7, which makes this 6. So the medium gray has a 7 already, so this can't be medium gray. Therefore, this is orange, and that's done as a region, so this can't be orange here. And so these are the regions here. Therefore, this is 6. So, yeah, pretty straightforward. Hopefully you didn't make the similar mistake here that I did, which said that this was 5 or less. This is 6 or less. That share the same false region and real region as a possibility. We basically were able to fix that bad assumption pretty quickly because it obviously ran into some problems. So, I don't know. I enjoyed these are these destruction puzzles, I guess? They're not chaos construction puzzle. They are chaos destruction puzzles. I don't know. They've been fun. But I also like, yeah, they're very similar to, you have to build up the regions too, along with basically using these circles to figure out where the real regions can be or where they can't be, right? Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.